Now, obviously, we know equations are to do with x's and y's and unknown values, okay? So we always want to let something be x. So let something be x. Now, on the easier questions, and we won't get to the really challenging ones at this stage, but we always want it to be just the same letter, so x, because obviously if we have two different letters, then it's more challenging to solve. So what we're going to look at in this question is what can I let be equal to x? So it says Tom has $5 more than Jim. Okay, so $5 more than Jim. So there's two ways I could let this happen. I could let Jim's money equal to x. So let's have a look at this case first. So let Jim's money equal x. That means that Jim has x dollars. So what does that mean about Tom? Well, it says in the question that Tom has $5 more than Jim. So hopefully if Jim has x dollars, then Tom has $5 more. We're just adding 5 onto it. So for example, if Jim was 10, Tom would be 15. If Jim was 100, Tom would be 105. We're just adding $5 on each time. Okay, but what we are told is that together they have $20. So what we can actually write is, if I do x plus 5, we know it's going to equal to 20. Okay? That's actually incorrect. Cut. So what we can actually now do is write an equation. Jim has x, Tom has x plus 5. So if I add both of their values together, or both of their monies together, we're being told that should add up to give $20. So we got Jim's money and we got Tom's money. So now what we've actually done is we've written an equation. Let's try to simplify it and then solve it. Well, x plus x is 2x plus 5 equals 20. This becomes a two-step equation. How do I get rid of the plus 5? Well, we take 5 away. So 2x equals $15. So x equals $7.50. So we should know that in this case, Jim has $7.50. Tom, who we know had $5 more than that, well, what's 5 plus $7.50? Well, that's $12.50. And if I add those two amounts together, look what we've got. We end up with $20. Okay. So you can see that, you know, that we're using algebra. Once we actually form the equation, it's just quite easy. It's quite solving it. Now, some people say, well, what happens if I did it the other way? What happens if for example, I didn't let Jim's money be x? What happens if I made a mistake by accident and I said Tom's equal x? Well, that's not a mistake, because that can actually work out as well. Let's have a look. Well, if Tom equals x, we know that Tom had $5 more than Jim. So if Tom's got $5 more, it means that Jim obviously has $5 less. And it just goes the same way. So in this case, we've got x plus x minus 5 equals 20. Okay, let's solve this now. 2x minus 5 equals 20. 2x equals, well, opposite of minus 5 is plus 5. So 20 plus 5 is 25. X equals, okay, how to get rid of that times 2? Well, we divide by 2. So we're left with $12.50. Okay, now you might say, hold on, but my 2x values are different. But remember, we let x be something different in the question. Here, the first one we let Jim have x dollars. This time we're letting Tom be x dollars. So in this case, Tom has $12.50, and we know that Jim has $5 less. So let's take $5 away from that, and we get that $7.50. It's just doing it the other way. We still get the same answers, okay, but we just find the value of somebody different. And that can happen for all these questions that we do today. Okay, so that's a fairly straightforward question, but you can still see it's challenging because we're trying to find that equation. But once we've got that equation, it's nice and easy. So always we need to look to let someone represent x, okay, or let x represent somebody's amount. Okay, so let's have a look at this question here. A rectangle is 3 times as long as it is wide. Sometimes, if you're talking about shapes, it can be a nice idea to draw them out. Now, it says that it is 3 times as long as it is wide. Well, let's say its width is x. So what does that mean about the length? Well, it's 3 times as long. So 3 times x is 3x. So I'm going to write that there, 3x there. So again, I let the width be x and the length be 3x. I prefer to do it this way because had I let the length be the length be x, then I would have had to let the width be x over 3, and that's just a little bit confusing. Okay, so first of all, it then says the perimeter is 60. Find the dimensions. Okay, so find the values of the length and the width. First of all, what does perimeter mean? Perimeter means that we add all the lengths together. So we've got x and we've got 3x, and hopefully you remember on the other side we've got 3x, and the other side there we've got x because they're the same length. So perimeter equals x plus 3x plus x plus 3x. I'm just trying to form a value for my perimeter. So x plus 3x is 4x, 5x, that equals 8x. Now what does 8x represent? The perimeter? We've been told the perimeter equals 60 centimeters. So that's where my equation comes into it. I'm going to write down 8x equals 60. I can put centimeters there if I want, you don't have to. Okay, so I formed my equation, so now let's solve it. Well, how do I get rid of the times by 8? We divide by 8. X equals, well, what is 60 divided by 8? Well, if you're not sure, you can just put that straight into your calculator. That comes down to be 7.5, and now we can put the centimeters in. Okay, so what have we found? We found the width to be 7.5 centimeters. We know that the length is 3 times that amount, which is going to equal to 22.5 centimeters. Therefore, I'm going to put that little therefore sign. The dimension of my rectangle is 7.5 centimeters by 22.5 centimeters. Okay, and we often write dimensions with little times. You can also say put by. It just means the length by the breadth. I could even write that way, just leave it there, that probably would have been suffice. Okay, let's go a little bit more challenging now. Sam is 6 years older than his sister Anna. Maria, Sam's mother, is 3 times Sam's age. The sum of their ages is 44 years. How old is each person? Well, look, they're both talking about Sam and looking at their ages in relation to Sam. So let's let Sam's age equal x. Okay, because they're both involving Sam. Okay, so Sam equals x. We're being told that Anna is 6 years. So we're being told that Sam is 6 years older than Anna. So Sam, x, is 6 more than what Anna is. So what does that mean? Well, if I take 6 away, it kind of means that Anna must be 6 years less than Sam. So obviously Anna is younger by 6 years. So we're taking 6 away. We're also being told that Sam's mother, Maria, is 3 times Sam's age. Well, Sam is x, so how do we write 3 times x? Well, it's just 3x. Okay, so far we've got some of our values in relation to x. And you notice that we have here all x values. It then says the sum, which means add, of their ages is 44. How old is each person? Well, so the sum means add. So if I add all of these things together, we know that equals 44. So 1x plus 1x is 2x. Okay, so x plus x is 2x plus 3x is 5x. I'm just going to simplify that out. Okay, so remember back to our equations. We're going to get rid of the minus 6 by plussing 6. So 5x equals 50. And then how do I get rid of that times 5? Well, we divide by 5. X equals 10. Now, make sure you don't just stop there, because often we solve, that's what we've done in the past. We've got X and we've gone, yep, we're finished. We have to answer the questions. It says, how old is each person? Okay, well, we found out Sam's age. Sam is 10 years old because he was the X. So that means that Anna is 6 years less than Sam. So 10 take away 6 equals 4. And we know that Maria, his mother, is 3 years, or 3 times his age. So 3 times 10 makes 30 years old. And look at that, I've got all my answers there. Okay, nice question. Very well set out. My last question, guys. Okay, so this is quite a challenging question. Only attempt this if you've been okay with the last couple of questions, but this really is jumping up a notch now. In my money box, I have only $1 and $2 coins. There are 84 coins in total, worth $139. How many $2 coins are there in my money box? So I need to let something be X. So I'm going to say let the number of $2 coins be X. So what does that mean for the number of $1 coins? Well, if I have X lots of $2 coins, and I've got 84 coins in total, then it means I've got 84 take away X. Because let's say I have 20 $2 coins, that means I've got 64 $1 coins. Okay. It says there are 84 coins in total, worth $139. Okay, so we've said there that the number of $2 coins is X. Now let's have a look at what they're actually worth. So let's see the $2 coins, how much are they worth? Well, if I've got X amount of $2 coins, well, they're all worth $2 each, so I've got 2 lots of X. How much are my $1 coins going to be worth? Well, obviously if I've got 5 coins, this is $5. So if I've got 84 take away X dollars coins, it's 84 take away X dollars. They gave me the same amount. Again, let's say I had 10 $2 coins, means I've got 2 times 10 is 20. If I got 10 $1 coins, 10 times 1 is 10. So that's why they stay the same. Now, I know if I then add these two amounts together, so if I've got my 2 lots of $2 coins and my 84 take away X lots of $1 coins, they add up to give $139 in total. I've actually come up with an equation here. Let's solve it. 2x minus 1x is just x, plus 84 equals 139. How can I get rid of that plus 84? Well, we take 84 away. So I'm now left with x is equal to 55. Remember, let's not stop there. We need to actually figure out what was x representing. Well, x represented the number of $2 coins. The number of $2 coins. The question then says how many $2 coins are in the money box. That's actually answered our question. So for the number of $2 coins, there were 55 coins worth. If we were asked to find how many $1 coins there were as well, then obviously it'd be 84 take away 55, which would equal 29. But again, the question they asked us was about the $2 coins. They might even ask how much would the $2 coins be worth, which we then work that out to be $110. Okay, really tough question. With all these questions, remember the process. You need to let something equal X, and then work from there. Create some type of an equation. Once you've got your equation, then it's a matter of solving it.